Hello, this is a recording of an Arduino setup that involves the temperature sensor DHT11, that involves a buzzer, a potentiometer for contrast, and an LCD panel, the 1602 specifically. 1602 because it has two rows of 16 characters each. The first thing, of course, I had to set up the port and the board. The obviously board is Arduino Uno, and in my case it's connected to COM1. And the second thing is also to install the libraries for the temperature sensor and for the LCD panel. So in this case, as you see here, include DHT-H. And if you see also that I already have it installed, right? The one that you need is the DHT sensor library by Adafruit, right? So usually if it's not installed, you press install, and if it's installed, then you get of course access to the sensor, and Arduino will be able to communicate with it. And the same thing with the liquid crystal library. Once those two libraries are included, and that means the Arduino is going to be able to communicate with those two peripherals, one sensor, one peripheral. Then, as you see here, the lines 4 and 5 are the ones that provide us with the ability to enable to select the register and to select also the data pins and the data lines that would be used. Now the LCD panel theoretically has eight pins for 8-bit type of sequences that could be transmitted or received, right? But in this case, of course, we're just going to write on the LCD panel. So we just send to the LCD panel. The LCD panel is going to be just kind of an output device. So we're going to just write into the LCD panel. So in this case, because we're selecting only 4 pins, obviously there's less wires involved, but most importantly, less pins from the Arduino to be used, because we may need the other pins for other functions. The only disadvantage is that instead of sending 8 bits at a time, it sends 4 bits at a time, right? So a byte will require 2 bits or two nibbles. Nibble is a 4-bit sequence, right? So it requires 2 nibbles before it can display a character. And the code that is used, usually they send the high order nibble, then the low order nibble, and if you want to see what the code looks like, as you see here, for example, for the simple characters from the keyboard, we can use sequence or strings in between quotations, right? So that is not a problem. But sometimes we need to have access to special symbols, like in this case, for example, the degree symbol for the temperature. So as you see here, the degree sample or symbol has a higher order nibble as 1101, and the lower order nibble is 1111. And so from that point of view, if you look at the decimal equivalent, that is if you write it as 1101 then 1111, you'll find that the decimal equivalent is 223. And this is the reason, for example, you see in the code, that we're using 223 to represent that character when we needed to display it. Okay, so in this case, so now back to the code. So you see in this line here, character 223 with LCD print, that's to print the degree symbol. Right? Whereas for temperature, humidity, percent, those exist already as part of the first 128 combinations of the ASCII code. So in between quotation marks, then there is no problem in displaying them. But for the degree symbol, as you see here, we needed to use the code for that specific symbol, right? Everything else is just in between quotation marks. So in this case, right, in this case, we define the symbol for the temperature sensor as pin 6, right? And if you see here that pin 6, well, obviously I'm hesitant to pull this out because I want to see the display, but you'll see that pin 6 is connected to the signal line of the temperature sensor. In this case, you see that the two pins on the right are just power and ground, and the left one, which is the blue line, is connected to pin 6 of the Arduino, right? So we defined it as pin 6, right? Now, we also defined pin 8 of the Arduino as an output, and where we have connected a buzzer. So you see here the buzzer, one pin is connected to ground, and the other pin is connected to pin 8. And the reason is that, I decided that instead of using an LED, maybe a sound, sometimes like if you exceed some threshold, may be welcome. It may be annoying in the laboratory because if everybody did that, there'll be chaos. But still, it's something that will be more, that bring more attention to an alert than just an LED that turns on or off. So, and also one way to practice with different peripherals and different elements, different interfacing elements that Arduino can work with. So in this case, again, we read the temperature from the sensor, right? And then then you see here that I display temp colon, then the temperature value, then degrees Celsius. It's in degrees Celsius. If you want to convert it to Fahrenheit, you can just the expression for the conversion. Then I go to the next line and I display the humidity, and then display the value of the humidity, and then percent. Delay that for 3 seconds, and then go back. And then before that, sorry, if the temperature is less than or equal to 25, then the buzzer would be silent, right, for 5 seconds, and then go back, right, because there is no else. But if it exceeds 25, then this would be skipped. Then this would be on, so it will go for a high. That means the buzzer will sound off for 2 seconds, then go back and start the loop again, right? Obviously, it's going to be on for as long as the temperature is greater than 25. So in this case, of course, when you put your hands on it or fingers, it warms up. It takes a little time, but unfortunately, when you remove your hand after it exceeds the 25 degrees, then it keeps going up, 26, 27, 28, before it starts going down. So obviously, in that case, the only way for me to deal with it is to remove the one of the lines from the buzzer, either power or ground, to keep it quiet. But once the temperature goes below 26, that means less than or equal to 25, then it goes silent again. So obviously, I wanted you to learn to figure out how to use the LCD panel, how to use the temperature sensor. You can remove some of the things that are not needed. You can put them all together. For the potentiometer, the outer terminals are connected to power and ground, and then the middle pin is connected to, in this case, to where? Okay, the middle pin is connected to the third pin from the left of the LCD panel. And in this case, if I go back to pin 3, that's VO, right? The control pin, right? For the contrast, it adjusts the contrast, right? But also we have the backlight, right, which are pin 15 and 16. In this case, of course, I used the fixed resistor, as you see here, right, and the other pin is connected to ground, right. The last pin is connected. Is it connected to ground? Let's see. Yes, it's connected to ground. And but theoretically, I used to use a potentiometer, but using only one outer terminal and the middle terminal as a variable resistor, right? And you can control the backlighting intensity, right? So the potentiometer is for the contrast, and this resistor, if it is a variable one, it can control the backlight to make it brighter, but the back of it. And this can decides the contrast. So when you play with it, you will see that you go to extreme. Either the screen would go blank, or the screen would be so high in intensity that then the characters will disappear into high level intensity squares or rectangles of pixels. So just to see here, for example, that I'm putting my fingers on a temperature sensor, right, the DHT11. It's not as sophisticated as the DHT22, but it can do the job properly. As you read here, it's 22 degrees and 60% humidity. It takes a little time for the temperature to change. In the meantime, we can see that we're using pin 5 as only a right. That means we made it 0, and that's the right operation, right? As you see here, 0 made it right operation. So we connected to ground to make sure we only right. And pin 6 is enable, and that is under control of the okay, here sometimes it has this tendency to go, see here, and obviously it exceeded the 25 degrees, and that's why you have this sound. And unfortunately, as I said, it takes a little time, so I'm gonna take off at least one wire to keep it silent. Then okay, it went up to 29 degrees, so it's even worse, right? It's gonna take even longer to reach 25 or less. So in the meantime, if you have any application for which you can think you can add other sensors, other peripherals, or make use of these in a very practical way, that would be what projects are about, right? It's multiple usage of different components, but turn it into an application. For example, right now is just the temperature, so the temperature could not only be displayed, could not only go to a buzzer, but instead of a buzzer, for example, you can connect it to a relay which turns on a fan, and the fan will bring the temperature down when it reaches a higher level. So I'm just thinking simple stuff, right? But you can turn on, for example, maybe a water flow.